Okay, we are live. Perfect. We're going to hop right in. Good morning, everyone. My name is Maddie Gwitt. I'm the Agronomy Marketing Manager here at QLF. I just want to thank you guys for joining us today. We know it's a busy time of year, and we really appreciate you guys taking time off to tune in. We hope your spring is off to a great start. So we'll get right into it. Joining me today are two QLF team members who know their stuff. Shannon Schumacher, our regional sales agronomist covering southeast Minnesota and northwest Wisconsin. And Anthony Roth, who manages our QLF greenhouse and helps with in-field support. And throughout the webinar, feel free to drop any questions into the question and answer box, and we'll tackle those at the end. So with that, Shannon and Anthony, take it away.
Thanks, Maddie. So we're going to start off here with talking about how when we add our L-CBF products to foliar or even foliar applications, how we can sweeten your tank mix. So with that said, this picture was taken probably about 4 or 5 years ago, and this kind of started our journey of looking into this. On the right-hand side, you can see the soybeans that were sprayed with, I believe it was Flexstar and Boost, and on the left side was just Flexstar. And so even though the plant has the genetics capability to not die from that herbicide, when we add that Boost to it, we saw that it had much less stress. So we can reduce that stress on that plant and then help our crop and help with a better yield. So this kind of started the journey. And I'll let Shannon talk about this slide.
Like Anthony said, we're noticing some really great plant health components when we added Boost to foliar mixes, and we wanted to kind of delve into why we were seeing such visual differences on foliar applications when we got to add that L-CBF in the tank. And the place that we started with was just with compatibility, and we wanted to make sure we are going to tank mix with different herbicides and different fungicides. We knew we did on a small scale, and we kind of delved further into that. And you can see on this slide there, it's a herbicide trial on the left and a fungicide trial on the right, different products. And once again, the goal of this trial was really just to ensure the compatibility of Boost with these products and to make sure that Boost did not have a negative effect on the efficacy of those active ingredients. We wanted to make sure that Boost was going to enhance the way that they worked and not hinder the way that they worked. And that really was where these trials started. You can see that we had success in these trials, not only in compatibility, which was the goal, but in all of these trials, we were able to see a yield bump, which was really just backing up what we were already seeing in the field in these herbicide trials. So once again, all of our L-CBF products are sugarcane molasses based. And why are we seeing the differences, the visual differences in the fields that we're seeing compared to other sugar products? And that's really where we came up with this tagline of more than just sugar. And it really truly means that when we deliver Boost to the field, or any L-CBF product for that matter, when we have molasses in the tank, yes, we are bringing sugar as a food source and as a carbon source to those farms to fuel our biology. But that version of sugar was still responding in those plants different than other sources of sugar on the market. And coming back full circle, molasses really is more than just sugar. There is a lot of, it is a complex carbon source, and it really is a food source for biology. It's quite recognizable to the plant because it is a plant byproduct itself. We like to call it the blood of the molasses plant. The chemical makeup of molasses actually very closely mimics root exudates. And as you can see from the nutrient profile on the right here, molasses has a whole nutrient profile beyond carbon or beyond a sugar source. And this is truly what sets a molasses-based product aside from other just quote unquote sugar products on the market to help reduce plant stress.
So when we were seeing those different results, we actually conducted studies on how the plants would perform. And so this actually, we used 2,4-D, glyphosate, and AMS, and then we also added 2 gallons of boost. So treatment A, the plant on the left, you can see just had that application of glyphosate, 2,4-D, and AMS, and that plant on the right side had that same herbicide treatment with 2 gallons of boost added to it. And you can see the plants were relatively at the same phase, like in life cycle, but like you can just see how much better growth that with the boost had it was able to work through that stressful situation from that herbicide. So same genetics of the soybean, same treatment, just adding that L-CBF component to it really helped that plant through that stressful situation. And so if that's not visual enough for you to see, like you can see what people are seeing in the field. And these are some more pictures showing that.
This is we're just going to go through a quick slideshow of some photos that I've had some submitted to myself and just other RSAs. It's really fun to just get these pictures from, this one's the combine, but from the sprayer, just from checking crops. And you can see in this slide, just out ahead, just maybe an inch above that bar there, you can see that there's a strip in that wheat field. And this was submitted from the Dakotas on a wheat trial. But it's really cool even to be able to see these plant health visuals come harvest time. So here's one example. This is another text we got from a grower in Iowa, actually, and this was about 12 hours after an Enlist application. Here is another one. This is a FlexStar application. This is about 24 hours after. This one was submitted from Wisconsin. Here is a FlexStar application, and this is just it's actually of that same field of the last one, but if you look close up here, you can see, the pigmentation difference on the left side here, and on the right side, we don't see that loss of pigmentation when we had boost in the tank.
And this is another visual experiment that I did in the greenhouse. So the way that this one came about, out in Iowa, we had a dealer that we wanted boost to go with their UAN, but they had a spray, like a burn down program that they were putting on a cover crop rye. And they wanted to know if the boost would affect that herbicide kill on the rye. So we conducted experiment in the greenhouse first just to test this out. So the first treatment there is just the regular herbicide program. And then the second treatment had 2.5 gallons of boost. And then the sixth treatment had 5 gallons of boost. And I had all the other different treatments were different variations of like how much boost we had in there. But from the pictures, you can see like where there was no boost, like the rye is starting to die and it's taken a little bit longer than where you had the boost in. Like where we had the boost, that rye is dying quicker. And we'll get into some of the reasons why we see those results. But so we did this in the greenhouse, it worked. And so then we had the confidence to go tell the dealer like, yep, you can do this out in the field and you'll be just fine. And then Shannon will share her experience in the field as well with it.
Yeah, I actually had a dealer and producer of mine take this trial to the field, and he was burning down some rye when he was applying his UAN. Cover cropping rye is very common here in Wisconsin, as I know it is across a lot of the Midwest. But it's really fun to see how some of our greenhouse trials really do get taken to the field and hold true. And you can just see that he texted me, I put boost with mine 16 hours, and you could see the rye dying already. It was pretty cool. So it's really fun to see us be able to take these greenhouse trials out to the field and have the same result and have our growers have success. And this is a really cool opportunity that QLF has with the greenhouse. So work with your RSA, and if you want to trial some of these little things, I'll volunteer Anthony here, but he's always willing. He's always willing to help with some small scale trials, and it's fun to try these things out before we take them to the field. And this is just one example where we had great success. And just one more kind of field side by side here. This is actually from Illinois, right on the Illinois-Indiana border. Had a grower go out and run Boost with his herbicide pass, and he was just thoroughly impressed with the way his weeds died and the lack of visual stress on his soybean crop, because he had some pretty good sized ragweed out there, as you can see from the picture. And he had a hot mix going out because he was really going after it. And this is really a cool testament to see when we add Boost to that tank. This is really just an opportunity to help our plants deal with the stress of metabolizing a herbicide. Now, when we go out there and spray a herbicide pass, you know, that herbicide pass doesn't know any difference between a weed and a growing crop. So both of those plants are going to take that herbicide in. And when we have Boost in the tank, both of those plants are going to take that Boost in. On the left side, you know, that Boost is helping that soybean to overcome that stress. On the right side, this is kind of funny to think of it this way, but it actually helps our weed to actually overcome that initial burn stress. And I like to use the example of mare's tail. If you battle mare's tail, you'll know that it's pretty common to go out there with a hot mix on mare's tail, and you'll get a good burn. Say we're spraying, you know, 6-8 inch mare's tail, you'll get a good burn, a good contact burn on that mare's tail, and you'll think you'll have a good kill. And maybe a week to 10 days later, you'll see that mare's tail start sprouting out the top again. It's very common. You know, a lot of us deal with this, and this is a pain. But one thing, when we add Boost to that tank, we give that weed a little bit of energy to overcome some of that herbicide stress just for about 12 to 24 hours. And in that 12 to 24 hours, our weed is actually able to take in more of that active ingredient and actually get a better kill. And just like Anthony showed in those rye pictures, we can actually then get a kill from the inside of the weed out rather than just burning the weed on the outside and hoping that actually kills the stem and the root of that plant. When we get more of that active ingredient and kind of promote that photosynthesis a little bit longer, we can get that active ingredient in that weed, and that's why we're seeing a better kill on some of these applications.
And then I'll just add a little bit there at the bottom. You can see, like, make sure you jar test. We do have application where the RSAs can put in your jar test and help do the calculation. So if anybody's looking for help with like jar testing, like reach out to your RSA and like we can help with the jar testing and help make sure that it's all going to work for you. So just want to make sure everybody knew that was available. So we're going to get into, like, there's a few factors that can affect foliar applications, not just the herbicide, but like your abiotic stresses, like the weather. So if it's hot and dry, the cuticle of the plant will be harder, like thicker. If it's, you know, tempered out, like there's humidity in there, like the cuticle isn't as thick, it's able to get into leaf better. And if a plant is too stressed out, it kind of shuts down. And so Shannon was sharing a little bit like that, where that ragweed, if it's too stressed out, it shuts down and it doesn't translocate the herbicide. So if it's super stressed, like when you're spraying, that's going to limit your effectiveness. pH of the products, that also affects its ability to get into the leaves. If you're like a lower pH, helps it not interact on the leaf surface, so then it allows it to absorb into the leaf better. Plant species and their morphology, like just the difference in plants and like their leaf structure and how they like orient to the sun makes a big difference of how your foliar applications are effective. And then also like the formulation of the spray mix. So again, if you can make that mix so like it sticks to the leaf, it stays there, it stays hydrated longer, it has like carbon base to it, those different types of things help formulate the spray mix, the whole combination better. And that's what we see, like when we get that L-CBF in there, like we can help that spray mix perform better. So before we get into like metabolizing of like the plant, just wanted to give you like what a leaf looks like a cutout. So you think of a leaf, it's flat, like you don't think there's multiple layers in there, but it actually, like this shows you on a microscopic level, So like there's three main parts to a leaf. There's the cuticle, which is like this waxy surface that helps prevent moisture loss, but it also helps prevent stuff getting in and out. The epidermis, and then the mesophyll. And so there's allowing stuff to get into the plant, like the stomata, the breathing holes on the bottom side of the plant. Stuff can actually get in there as well, but if you look at the top, they're like our cells are not, it's not like one continuous layer. There's like these little cracks, and that's actually how we can help infiltrate into the leaf as well, and then get it absorbed down into the vascular bundle, like the xylem and phloem, where then it can actually translocate, whether it's a herbicide or nutrition, those types of things. So when plants metabolize, it requires energy and nutrients, and when it does, it's taking those, robbing those of the plant, then it's reducing the growth and photosynthesis. And that's what we've showed you, all those pictures. Like that plant is under stress because it's trying to deal with metabolizing the herbicide versus grow and synthesize, like for plant production. We've seen those pictures. And so like to get into the plant metabolizing part, there's basically, I know I have 4 here, but there's basically 3 main phases to it. And so I'll try to walk you through that and help you visualize how the plant is dealing with it. So phase 1 is the conversion or the metabolism phase. And I'm gonna, like, so a visual, like we think of like an intruder coming into our house. So a plant, a herbicide is an intruder coming into the plant. All right, we have an intruder coming into our house. They have a knife. If we disarm that intruder, if you disarm that knife from them, they become less harmful. So plants aren't mobile like you and I are, so they have to use like chemistry to help immobilize or disarm their intruder. So how they do that is like they can remove different, so like simazine here, if they remove the chloride ion and put a hydroxyl group there, it makes it 1,000 times less toxic. So they use their chemistry to help break and change that molecule. So it'd be like just taking the knife away from that intruder. It makes them a lot less harmful. Plant does the same thing with these herbicides. They change the structure in order to make them less toxic. So phase 2 is the conjugation phase. And so, and again, liken it to like the intruder comes in, you disarm them. The second phase is to bind them. So you put handcuffs on them. And so how does a plant do this? It can actually use like sugars and amino acids, so it binds to those molecules that it has now broken apart. And when it binds it, it's able to transport it somewhere else and not to like a growing point or to like the point where the herbicide affects the plant. So basically, you got to handcuff it, and then that way I can transport it so it doesn't hurt anything along the way. And then the third phase is like secondary conversion or transport into a vacuole. And so, and again, if you have an intruder into your house, this is where you put them in jail so that they can't do any more harm. So the plants, how they do that, so after they transport it, they put it like in a vacuole, which is similar to like a closet. So it's this open storage vessel, and it can stick it in there, and then it renders that chemical useless or less harmful. They can also deposit it in cell walls or cellulose. So like it'll build it in the cell walls and like kind of like, again, like put it in jail, and that it can't react with any of the sensitive parts in the plant. So the plants kind of have a 3-step process where they metabolize this, and this all takes energy. And like that, when we add our L-CBF or like boost, we can help give that energy for them to help do these processes. Another way to like help you understand, again, each plant is just a little bit different on how susceptible it is to herbicides. So for example, here you see 3 different plant species, and it tells you like on the very right side whether it's susceptible, tolerant, or very susceptible. And if you look at the half-life in there, so scepter in common cocklebur is 99% of it is left after 30 days in the plant. And then so like velvet leaf is only 12 days. So there's a difference of susceptibility, and that helps explain why certain plants need more of a dose in order to actually get the kill, and how different plants metabolize different as well. They have the genetics to be able to do that. So.
All right, and this is really all rounding out, in order to understand why L-CBF plays a role in, promoting herbicide breakdown and also mitigating stress in our plants. It really helps us to be able to understand what Anthony just went through and really understand what the plant is doing with those herbicides once it enters them and how they work. And I think his little intruder analogy there is very relatable, and it's something he told me a long time ago, and it's something that's stuck in my head. So I hope that works for you guys as well. But when we add L-CBF to that process that Anthony just touched on, there really are a few key benefits that we kind of have learned throughout the years of working with our product. And a large one is just hitting the target. Two, we do see that stress mitigation. We see that over and over again, and the visual pictures are a really fun part of that. And lastly, adding L-CBF really does help and promote that herbicide breakdown process within the plant that Anthony just touched on, whether it is in a weed or it is in a crop. Either way, the plants have to go through that process, and whether that process kills them or not, like Anthony said, is dependent on their tolerance. And just understanding that has really been a benefit, and L-CBF helps that process to occur.
So on that trifoliate effect, like we haven't touched on like hitting the target. One of the things that we've also noticed is like when we hit that leaf, like obviously we can stick to the leaf just with that molasses part of it, but then like decreasing the surface tension. So the diagram on the left, you can see if you have a high surface tension, that the droplets stay together. And so like it beads up and runs off. You don't want that. You want the surface tension to be low, and you want that droplet to spread across the leaf. And that's where it actually absorbs through that cuticle better when you have that decreased surface tension, and then like you help that droplet stay hydrated longer. So we see multiple benefits with this, like where you might buy 2 or 3 products in order to achieve this. But one, we can stick it to the leaf. 2, we can help keep that droplet hydrated longer, which is like a humectant property. And another way that I've heard it said before that I like is a droplet survivability. The longer that you can keep that droplet there and hydrated, that allows that much more for the nutrition or the herbicide to absorb into the leaf. And then on the right side, you can see the picture of like just water on the left hand there. And then on the right side is boost. And so you can again see that difference in surface tension and that ability for that leaf to stay on that leaf and take it in. So that's part of hitting the target. The other part of hitting the target is like your droplet size and performance. So this is a study we did in Nebraska in a wind tunnel, and I highlighted one of the columns there, and that is the percentage of droplets that are 150 microns or less. So if your droplet's 150 microns or less, it has the ability to drift farther away and not hit your target. And on the very top row, you'll see that's the percentage of droplets of just Roundup and water. And then the second row, you'll see it's Roundup with a gallon of boost. And on the third row, you'll see it's Roundup with 2 gallons of boost. And if you look at the numbers, you can see like there's roughly 32% of the droplets are prone to drifting without boost. And when you put 1 gallon there, it's at like 28, a little less than 28%. And then with 2 gallons, it drops it below 25%. So you can see that as we add more boost in there, we actually help that droplet performance. And then statistically, there is a difference between no boost and 1 gallon of boost, and then there is a statistical difference between 1 gallon of boost and 2 gallons of boost. So what that's telling us with 95% confidence, we can say that when you add 2 gallons of boost there, you're going to change your droplet size and performance. The second part of that, there's a relative span measurement. And again, you can see like Roundup by itself versus 1 and 2 gallons of boost. So what relative span tells us is like how consistent your droplets are. I don't want a whole bunch of droplets that are really big and really small. I want them in the sweet spot, no pun intended. So we want them bigger than 150 microns and less than that, like 500. And so it's really consistent so that we get an even coverage across the field. And what this shows us is that when we added 1 gallon of boost, we increased that relative span. And when we added 2 gallons, it did the same thing, but there wasn't a statistic difference between 1 and 2 gallons. So when we add it, we improve droplet consistency, and that's part of hitting our target. And then the next slide is videos of like aerial application, like actually going through planes, and like we can go through helicopters and drones as well, but we actually got some GoPro footage of it being applied through planes. So I'm going to start that for you guys. It's got a little bit of lag, so hold on. So you can actually see like the ribbon laying it down. And a lot of guys have mentioned how they can spray in windier conditions and still get a really great application and hit their target. A lot of times they'll mention how it lays down so nice for them. Just it falls straight down versus like trying to drift away. They have a different pattern almost. This is
All
just
right, and
another
this is
picture. Go
yeah,
ahead, Shannon.
this is just another picture. This is actually one we caught, obviously with a pretty good camera, but this is just a really cool picture of how having boost in that tank really holds those droplets together, and you can really see those droplets coming out of that Haggy right there.
So one of the questions that will get asked a lot is like, where do you tank mix, like where in the list order? And so I would say a majority of them add it like with, you have your water and then add the boost, and then like the other common places at the end. So either add it up front with the water so then you can hot load your stuff, or add it at the very end. Those are the two places that we have found the best success with.
And why it works in those two places is because we need a majority of our carrier to be in the tank. You know, boost is a very concentrated product, and oftentimes herbicides and chemicals are very concentrated products. So we need to create space in the tank mix for that tank mix to hold on to all the goods that we're adding to it. So really the key for success here with a tank mix procedure is just make sure you have enough carrier, and you're not, especially in an induction cone, make sure we're not just dumping chemical on top of chemical, and we are rinsing that cone out in between. That's really going to set you up for success when mixing. And we've talked about a lot about these kind of tank partner characteristics today, and we haven't really spent any time talking about really the yield boost we get out of doing all these things, and this is truly where it started, and this is just one quick trial, but we have so many we could share of foliar success. But we, in addition to all those properties, you know, hitting our target, mitigating stress, promoting herbicide breakdown, you know, we haven't forgotten about yield, because yield is important too, and especially at that 2-gallon rate on soybeans with boost, we see a great return on investment. And even looking at some of our other L-CBF products, you know, you can plug and play with what fits right on your farm, but having that extra carbon, there's a lot of those tank partner benefits, but don't forget about yield, because that's a big benefit too. And really lastly, I just kind of want to leave you with a thought of, you know, how your crop protection really is affecting your crop. Because most oftentimes we think about how our crop protection is affecting what we want it to, which is usually our weeds or our fungal population or something like that. But we really have to consider how those products are affecting our crop as well, and help our crop be able to manage through the stresses of some of those products. So building a program around carbon, we've really seen success with that. And that's really what we wanted to leave you guys with. We will answer a few questions if there are any. Anything else to add there, Anthony?
Oh, I think they pretty much covered it. Like, lots of reasons to have it part of your tank program, and just continually feeding the crop and feeding biology.
Perfect. Yeah, thank you guys. I don't see any questions as of now. But if
Perfect.
anyone does have
We did so
questions,
well, they have no questions.
yeah. But if anyone does have any questions that come up post webinar, I will be sending out Shannon and Anthony's contact info along with the recording of the webinar. Oh, we have a question. The most used rate on Boost is what?
2 gallons per acre in a foliar pass is where we have seen the most success. You will have to play with that rate and see what works best on your farm. I have some growers that do run at that 1 gallon of Boost per acre rate, and it does work to get those tank partner properties that Anthony shared about. But really, our highest return on investment is at that 2 gallon rate, because that's where we start to see yield jump up as well as grabbing all those tank partner properties.
Perfect. Yeah, I don't see any more. So yeah, with that, thank you guys for tuning in. Like I said, if you have any more questions, you can feel free to reach out to Shannon or Anthony. So, okay.
Thanks, everyone.
Thank you.